Hey guys, Professor Sweeting here. We're going to finish the semester by talking about identification numbers, which are, simply put, strings of numerals, numbers, digits, used for identification purposes, such as identifying products in a store or people in a country. Although this base purpose is pretty straightforward, we'll soon see that identification numbers can be designed to provide much more than a simple mapping between objects and strings of digits. In this video, we'll just be discussing the general concept of identification numbers, including their usage, enhancement via number schemes, and some examples. However, as a warning, this material is going to get far more computational than anything we've done before, so be prepared. Alright, so let's start by discussing the following situation. A distribution company is wanting to create a numeric labeling system for their products in their warehouse. While they could just go with a simple labeling of each product in numerical order, for example starting with 1 and incrementing for each product, they ideally would want these labels to include some basic information about the products they refer to. For example, what category of product it is, its location in the warehouse, etc. And they'd want these numbers to be compact and amenable to electronic transmission. This way, the transmission and storage of product information would be far more efficient since it could be easily digitized and would already be bundled within the identification number. Therefore, they may do something such as use the first two digits to represent what section of the warehouse the product is located in, for example 12 for the refrigerated section, the second pair of digits to represent a specific shelf in that section, for example 13 for the dairy shelf, and the next pair of digits for the product category, for example 04 for cheese, and the last 6 digits for the batch number and brand information. Such a system for identification numbers is called a number scheme. A cleverly designed number scheme can do wonders for the organization and efficiency of the business organization using them. All right, so most of you are probably well aware of some well-known examples of identification numbers, but are probably less aware of their underlying schemes. Such examples include zip codes, which provide specific operational information used by the United States Postal Service, such as what post office district and what office within that district is responsible for a particular address. So here's an example, right, of a zip code. Hopefully that's visible, right? So the first digit would represent the national area, the second digit, the sectional center, right? And then the second two digits, the sectional center, and then the last two digits, the associate post office or delivery area, right? So we see how the digit is conveying information that's used operationally, right? And so we don't see this when we pass around these digits, but that's what it represents, right? Another such example of a well-known identification number are VIN numbers for identifying cars. And these numbers include all manner of information about the cars they're assigned to, right? So here's an example of a VIN number. Right, so we can see that the first digit is reserved for the country that the car was manufactured in, right? The second digit would be given to the manufacturer of the car. The third digit would be the vehicle type. Fourth digit, the body type, sedan or sport, that sort of thing. The fifth digit, the engine. The sixth digit, the series. Seventh digit, the restraint. Eighth digit, the model. Ninth digit would be a check digit, which we'll talk about later. 10th digit, the model year. 11th digit, the plant. And then the serial number of the vehicle, which identifies a unique vehicle, right? So these might be shared among the same make and model of a vehicle. But as you can see, in this number, we're conveying a lot of information about the product. So, if you're talking to an insurance company, right? You can just give them the VIN number and you've already transmitted all, auto insurance company. And then in doing so and giving them this number, you're already giving them maybe all of the information pertaining to the vehicle that you're looking to insure. So it really makes efficient the transference of information, right? So a number scheme, there's a number scheme associated with the number itself, right? Another example of a well-known number scheme is ISBN numbers for identifying books. And so we can look at an ISBN number here, right? So we see how we have different parts of the number representing different things, or encoding different or additional information about the things that they're identifying. So the first three numbers we see is the prefix, so we know it's an ISBN number, because there may be another number that's maybe issued by the same standard that has the similar format, so we want to be able to distinguish between that number or those types of identification numbers and ISBN numbers. So that's what those 3 digits would be used for. The next digit, right, the 4th digit would be used for the country or the language of the book, right? The next series of digits would be for the publisher of the book, and then the last two would be, or second to last one would be for the title and format of the book, and the last would be the check digit. So we see how this digit is this identification number is kind of encoding additional information about the book that might be of interest operationally. Say if libraries were to be passing around ISBN numbers about a book, they no longer have to say like, oh, what's the identification number of the book, and maybe look it up in a database. They can just kind of look it up in a database for additional information or details about that book. They can just read those details directly from the number that was transmitted to them, right? So that's one major advantage of a number scheme. All right, so you may have noticed that in the case of the ISBN number and in the case of the VIN number, right, which I put away, one digit was reserved as a check digit, right? So such a digit is used for checking and sometimes even correcting errors in the transmission of identification numbers. So this is yet another benefit of a cleverly designed number scheme. So in the next video, we're going to take a closer look at the use of check digits within number schemes for the aforementioned examples and more. Specifically, we'll see the many ways in which this one special digit can help detect when other digits have been flipped, scrambled, or are missing based on some mathematical relationship it shares with the rest of the digits in the number. Right? So we'll see how this digit helps us catch, helps us catch errors in all of these other digits for the number, right? So say, for example, in transmitting this ISBN number, this 6 was flipped to a 7. Well, this check digit, based on what scheme is being used for the check digit, right? So there's a separate scheme within the number scheme that revolves around the check digit and how it helps us detect errors. We'll see whether it can catch that error, right? If this were to be missing or switched with one of the other numbers in the digit, or changed, if I hadn't said that already, so maybe a 7 or something. So we'll see that not all schemes are equal, and some schemes are better at catching certain errors than others, right? Something to keep in mind with these number schemes is that generally, the more features that they incorporate, the longer, right, or the more information about the product that they kind of include, the longer they are, the more complicated they are to store and maybe retrieve, and the more prone they are to errors, because there are more digits that can be kind of potentially corrupted in their transmission. So there's always an opportunity cost when it comes with designing these number schemes, right? So it's just the same as we saw with the algorithms, right? So you can have simple algorithms that are useful for just getting the job done, right? As we had seen in the bin packing and transportation problems, right? But then you can have other algorithms which produce better results, right? More optimal results, but they're more complicated, right? And maybe more prone to error or something. Well, not really if a computer's doing them. But okay, so that's what we'll be doing in the next video. So this is a short video, and I hope you found it informative, because a lot of what we'll see in when discussing these identification numbers, you might have experienced in real life, without even noticing. So I'll see you in the next video. Bye.